Hey there guys, today we're going to be starting our new unit on chemical reactions, and specifically today we're going to be looking into the very beginning of enzymes. I think this will be a really cool chapter, and it's stuff that applies to pretty much what you do in everyday life. So, first of all, we're going to define what a chemical reaction is, okay? And we're going to say that a chemical reaction is a, that's way too thick, huh? Let's go for something a little thinner. Here we go. Chemical reaction is a process, okay? And what it does is that it transforms one set of compounds, right, that's a bunch of elements, into a different set. So what's going into the chemical reaction is different than what's coming out, okay? Those things that go into the chemical reaction, we call these reactants. This is because they react with one another. Okay. And the things that come out of a chemical reaction we call the products. Okay? And the products are what is produced. So again, we have these reactants. They go into the chemical reaction, and they are what is reacting with one another. Then we have the products, which are what comes out of the chemical reaction, and they are what is produced. Okay, so very straightforward, and those are words that you should definitely know. Okay, so what we need to look at next is what happens during a chemical reaction. Okay, and if you guys can think back all the way back to Unit 2 when we started talking about water and stuff, what happens is that chemical bonds, okay, these are, remember, what holds two or more molecules together. All right, that's what a chemical bond is. Okay, and these chemical bonds are either broken between two molecules or they're formed. Okay, and again, this is occurring between the reactants, right? The bonds are either being broken between these two reactants or they're being formed between them. Okay, some reactions occur quickly. They're very fast reactions. Others are slower. And these take more time, okay? Some examples of reactions we actually have right here. So one of them is actually salt. Okay, what happens in salt is that we have one atom of sodium, and that combines with one atom of chloride, okay, as you can see down here, and this is what creates NaCl, and this is table salt. This is an example of a quick reaction, okay? This can happen very, very fast. It's not difficult. Now, conversely, what we have down here, we have steel nails, okay? And when these combine plus water, what can happen, right, is that these nails become rusty. All right, and this is an example of a slow reaction. Okay, so there are some examples of chemical reactions for us, okay? But what goes on in these chemical reactions often involves energy, everything that goes on in our body involves energy. All right, now one of the most important things that we're going to learn today is that the symbol for free energy, it looks like this. It's called delta G. Okay, it's a triangle in the letter G. Okay, that's the symbol for free energy. Okay, and there are reactions that release energy. Okay, these are known to have a negative delta G. Okay, they have negative energy. That means they're releasing this energy. I know, it's a little backwards in your mind sequence, right? And then there are those that consume energy, okay? And these are known to have a plus delta G. Positive delta G means energy is consumed. Think of consumed like eating, okay? These reactions require energy to work, okay? The reactions that release chemical energy, these are called exergonic. Exergonic reactions, okay? Remember, these have a negative delta G, okay? I know that's not clear, so I'm going to try writing this in yellow as well. Negative delta G, okay? That's the important part there. These reactions involve a bigger molecule, okay? So something bigger being broken down into something small, okay? So what's going on here is that chemical bonds are being broken. Energy is released. Okay, chemical bonds are broken, energy is released. These go on in exergonic reactions. Okay, why exergonic reactions are important is because this is what allows our body to obtain energy when food is broken down. Okay, that's why we have to eat, because our body takes the food we eat, it breaks it down into really small molecules by breaking lots of bonds, and when it breaks lots of bonds, it creates energy. Okay, so up here is basically just a really cool example of what we were just talking about. Okay, so exergonic reactions, now notice delta G is less than 0. That basically means that it's negative. Okay, energy is released. And you can see here, right, we have reactant A, reactant B, and what this produces in the end, okay, is we get two products as well as energy. Okay, 1, 2, we get 3 things out because energy is being produced from bonds being broken. And how we can imagine that this is going on in the body is basically simply by looking at this photograph, right? When you eat bread, right, this gets broken down into glucose. And if you guys remember, this is simply sugar, right? When you eat meats, this is broken down into amino acids. And when you eat fats, right, fats get broken down into fatty acids. All things that we learned about in our last chapter, right? But again, what all 3 of these things on the right side are, right? It's all of these plus energy. I'm going to try and write that even smaller for you guys, because I know that's not the most clear thing. Okay, plus energy, right? You're getting each of these molecules and you're getting energy out of this, and that's the important part to remember. Okay, now again, I want you guys to write this twice just because it's so important, right? The symbol of free energy, right? You guys should all be writing this before I even say it. Remember, it's delta G. And we have the reactions that release energy and those that consume it. Now, this was talked about in the last slide. And this is going to be on this slide. Okay, so chemical reactions that consume energy, we call these endergonic. Okay, endergonic. These are when we have small molecules that are being fused together, creating bigger molecules. So instead of bonds being broken, bonds are being formed. okay? And so this is how our body stores energy, right? When we have broken down the glucose, or we've broken down, the meat into amino acids, what can happen is that these amino acids, these glucose molecules can join together again and allow us to store energy, right? And we need to store energy sometimes. And so up here we have the opposite example, right? For an endergonic, you need energy as well in your reactant. So we have reactant A, reactant B, but we also have energy. Okay, and in turn our products, right, which is the outcome of the chemical reaction, is only C and D, right? There's no energy in our products. Okay, and the way that I am depicting this down here, it's like a bunch of these smaller molecules. They all come together, right? And you guys can even label this if you'd like to, right? Small, right, becomes these large things. Okay, it's the glucose that fuses together to form bread. It's the amino acids that fuse together to form meat. It's the fatty acids that fuse together to form margarine. Right, these are all examples of endergonic reactions. Some simple ways to remember these. I like to think of exergonic. Think of this as an X, okay? And so when you have, right, if we had a double bond between two carbons, imagine in an exergonic reaction, right, you put a big X right there. Because what's exactly happening is that you're breaking the chemical bond between these two carbons, right? So exergonic equals bonds are X'd out. Okay, and that should be a pretty good way to remember it. Exergonic bonds are X'd out. And you can even do that right there as I did, okay? So what I want you guys to do now is basically just define this vocab and then raise your hand so I can pair you up with a partner to start doing some work. Okay, I hope you guys are enjoying this new unit.